we are going to be finding trig values given other trig values. So today we're going to be looking at especially these Pythagorean identities. We should already know these reciprocal identities and the quotient identities. So the Pythagorean identities come from the Pythagorean theorem and the unit circle. So if you were to look at the unit circle, say we take any point, and remember the points x, y are cosine, sine. Cosine is the x coordinate, sine is the y coordinate. If we were to draw a right triangle, we know that the hypotenuse is 1 because that's the unit circle's radius. This x coordinate is cosine, so that means this length right here is cosine. And the y coordinate is sine, so the height we could say is sine. And Pythagorean theorem says that on a right triangle, a squared plus b squared equals c squared. So for our unit circle, we can write that a and b is cosine and sine. So we have cosine squared plus sine squared equals 1 squared, or 1. So that is how we get this identity right here from triangles in the unit circle. That's why it's called Pythagorean identity, because it comes from the Pythagorean theorem. These other two identities follow from this first identity, so I'll show you how that's done. So if we have sine squared theta plus cosine squared theta equals 1, we can divide each of these by cosine squared. So we're dividing both sides of the equation by cosine squared, which is allowed. Okay, if we use our identities, sine over cosine is tangent. So that will become tangent squared theta. Cosine over cosine is 1. And 1 over cosine, if you look at our reciprocal identities, 1 over cosine is secant. So that can become secant squared theta. And this is where we get that second identity. We can do the same thing, only divide by sine in order to get the other identity. So this time we're dividing by sine squared on both sides, which means we're dividing everything by sine squared. So sine squared over sine squared is 1. Cosine squared over sine squared. Cosine over sine is cotangent. So this will be cotangent squared theta. And 1 over sine squared, well, 1 over sine is cosecant. So that will be cosecant squared theta. So we get these two additional Pythagorean identities by tweaking and manipulating that first Pythagorean identity. So let's go ahead and use those to solve today's problems. We want to find the exact value of cosine theta if we know sine theta is 1/4 and theta is between 90 degrees and 180 degrees. So because we're dealing with cosine and sine, we can go ahead and use that Pythagorean identity, the basic one with the sine and the cosine. So we have sine squared theta plus cosine squared theta equals 1. We know sine is 1/4, so let's plug that in for sine. So we get 1/16 plus cosine squared theta equals 1. Subtract the 1/16 over, and we get cosine squared theta equals, let's see, 1 minus 1/16 is 15/16. And then to solve for cosine, which is what we're looking for up here, we take the square root of both sides. So we get cosine theta is equal to plus or minus square root of 15 over 4. Now, this is where the little angle range comes in handy, because we don't know if the cosine is the positive square root of 15 over 4 or the negative square root of 15 over 4. But if we were to draw our graph with our unit circle, we are between 90 and 180 degrees, so that would be right here, this little section. And cosine represents the x values, so you want to think, what sign will the x coordinates have in this second quadrant right here? Well, the cosines, or the x values, will have a negative sign. So that'll be negative, so that means that our cosine with the given angle range is going to be the negative square root of 15 over 4. So that was negative x. Okay, next one. This time we're finding the exact value of cosecant if cotangent is negative 3/5, and we know theta is between 270 and 360 degrees. So because we're using cosecant and cotangent, we're going to use this identity right here. So let's write that down. 1 plus, let me remind myself. Okay, cotangent squared equals cosecant squared. Okay, we know cotangent is negative 3/5, so we'll plug that into the cotangent. And we get 1 plus 9/25 equals cosecant squared. And 1 is 25/25, so 25/25 plus 9/25 is 34/25. To solve for cosecant, we take the square root, and we get cosecant theta is equal to plus or minus square root of 34 over 5. Okay, so again, we don't know whether the cosecant is positive or negative. So we look at our little angle range. If we look at our unit circle, between 270 degrees and 360, that's this right over here. Recall that cosecant is 1 over sine, and sine is the y value. So if you look over here at this quadrant, the y values are going to be negative. So that's going to give us negative y's, which means that cosecant has to be negative in that quadrant. So cosecant theta would equal negative square root of 34 over 5.